Hello, this is Mr. Stansbury. I'm going to take you through the notes on using triangle similarity. At the end of this, you should be able to say, I can show that triangles are similar and I can use similar triangles to solve problems. So, first problem here. Clarissa is one of the surveyors hired to help determine land boundaries. She needs to find the distance across a ravine. Here's the ravine. She thinks that she can use properties of similar triangles to find the distance. She locates points A, B, C, D, and E and takes the measurements shown. Okay, so we've got all this info here. Which similarity criterion, if any, can be used to show that triangle ABC is similar to triangle DEC? So, 61. We know that since these angles are straight across from each other, these are vertical angles. So this is also going to be 61 degrees, right? We know that for sure. Let's see. Now we have to figure out if these sides are going to be proportional, but we only have that to that. 61. Oh, okay. 61, 64. Let's figure out what this last angle is, right? So let's do 61 plus 64 plus the measure of angle E has to equal 180 for sure, right? So we add those two together, that's 125, plus the measure of angle E has to equal 180. So we subtract 125 from both sides, and we get that the measure of angle E is going to be 55 degrees. So this is 55 degrees. And look, this is 55 and 61. This is 61 and 55. So we know for sure, because we have two similar angles, we have, let's write it down here, which similarity criterion, if any, can be used to show that they are similar. We can use angle. Okay, so we use vertical angles and the triangle sum theorem. All angles have to add up to 180 in a triangle to show that we have angle-angle similarity. Okay. Number 2, triangles are similar, so the corresponding sides are proportional. Complete and solve the proportion to find the distance AB. Okay, so we've got 65 is here, and then we've got AB is this one here. Yeah, I guess just write that. All right. So let's do this. 65 is on the small triangle. So you can either write small here or here. I'm going to do small here and large triangle here. And then 65 is this piece here. So it's going to actually be similar to this 85 over here. So that's going to be 85. And then AB is going to be similar to this opposite side over here, so of the small triangle. So that's going to be 55, right? So to figure out what AB is, let's do cross products. So we've got 55 times 85 has to equal 65 times AB. Okay. So let's do 55 times 85. It gives us 4675 equals 65 AB. Divide both sides by 65, and that will tell us that side AB is, so divide by 65, 71.9. Okay, so we get that AB is 71.9, and these are all in meters, so don't forget to put your label on there. All right. All right, we got one last example. Let's take a quick comedy break first.
Okay, stop. Let's see what happens. Oh.
All right. Let's see this one here. Find CB, and this one find XY. Now, super important on this. We must first prove that the triangles are similar before we can go through and use our triangle similarity rules to figure out what's going on. So first, show that they're similar. Okay, so we know of this triangle we got CBD, and then we also got this bigger one, CAE. right? We know that this angle up here, has to be the same on both triangles because it's the exact same triangle. So not that you have to do this, but just to kind of help out a little bit. So let's see, here's the big triangle. I'll draw the big triangle and the little triangle to show you. Here's the two triangles. So we know that CAE, the angle ACE, this C has to be the same as this C here, right? So those have to be similar. And it tells us in there that B has to be similar to A. So look, we have angle similarity, right? So we now know that they're similar. So now that we know they're similar, now we can start doing our proportions here. So let's see, we know the short side of this here is 20, the bottom side, and the bottom side of this is 35. And then this left side over here is, well, let's see, let's do this. We know that this is X. So this is X, and then this is going to be X plus the 12. So we got X plus 12. Okay, so now we can set this up and try to find what CB is, which is the X, which is the part that we're looking for, right? So let's do this. I'm going to go big triangle and small triangle, and then we're going to do, I don't know, let's say I'm going to do the left side and the bottom. Okay, so on the big triangle, the left side is X plus 12. And on the big triangle, the bottom is 35. On the small triangle, the left side is X. And then the bottom part is 20. So now we can just do cross products again. Okay, so we've got 35x is going to equal 20 times x plus 12. Super important to remember that you got to distribute this 20 to both of these parts. Both of these terms over here. That's what I was trying to spit out. 35x equals 20x plus 20 times 12. I guess I could have just done 2 times 12. Yeah. 240. All right. And then let's move our x's over to one side. Subtract 20x. 15 is 240. 15x. Divide both sides by 15. And we will find what our x is. So 240 divided by 15 gives us that x is 16. So this side up here is 16. That is CB. So CB equals 16. Okay. For B, let's try this in a different color. We've got find XY. Okay, so we know that this angle is the same as this angle. And look, vertical angles, we know that that angle has to be the same as that angle. So we have angle similarity. So now we can set these up, right? Okay. Now, let's see, XY is what we're looking for. So we're looking for this piece right here. Now, when you have these, where you got these vertical angles going on here, let's do this. Let's do big. We got this one's the big one. This one's the little one. And little. And then we've got, let's say, the side away from the vertical angle. I'm going to call that the O for the outside. And the side that's next to the vertical angle, N for next to. So on the big triangle, the outside is 38. And on the little triangle, the outside is 22. Now, the part that's next to, this 30, when you got these vertical angles, these two are going to be the similar proportional sides, and then these two are going to be the proportional sides. Because basically, if you think about this, if you take this from right there, take that point and you rotate it around to go right on top of that, that means this side right here, and that's going to be proportional. This side right here ends up over there, and this side here ends up over there. So anyway, we're going to have to set it up as on the big triangle, the side next to the vertical angle is 30, and the side next to this one is x. So then cross multiply. And away we go. So we got 38x equals 30 times 22. So 3 times 22 is 66. Add a 0 on there. Divide both sides by 38. That's a 3. And we get x equals, let's see, 660 divided by 38 gives us 17.4. Okay. All right. That's all there is for this here, for the notes on using triangle similarity. If you have any further questions, please feel free to ask in class. Thanks.